Okay, so we did this problem in class already, but I wanted to take a fresh look at it without the brute force approach that we used previously. So before, when we looked at this, we said how many different ways can the 4 students be arranged in their seats, right? And we sort of took this brute force approach. We said, well, we could arrange them A, B, C, and D, right? Or then we could do A, B, D, and C, or we could do A, and then C, and then B, D. Or we could do A, and then C, and then we go D and B, and then finally A to D, B to C, or A to D, C to B. Now, of course, that's not all the ways. What we did after this was we said, well, here's 6 ways that Alex can sit in the first seat, right? 1, 2, 3, 4, 5, 6. What if we then put Brian in the first seat? Well, that'll be another 6 ways. Charles in the first seat, and David. So 6 plus 6 plus 6 plus 6, 24 ways. There's actually a little bit more sophisticated way to look at this, and that's what I want to show you here and show you how the calculator is going to be super helpful in that. What we did there was a brute force approach to, in math, what we call a factorial. And a factorial works like this. We say, well, there's 4 people that can sit in the first seat, times 3 that can sit in the second once the first seat is taken, times 2 that are left, and then times another 1. 4 times 3 times 2 times 1. This is also known as 4 with the exclamation point, and this is called a factorial. So on your calculator, I want to show you where this lives. Under your probability button, so if I type the number 4 and I click on my probability button, you're going to see number 3 is my factorial. Okay? I don't want to key press. Yeah, I'm going to go here. So on my screen, I'll see 4 factorial, and I press enter, and I get 24. Okay? So a little bit easier way to compute that, a little bit more sophisticated, and we are going to be looking at factorials now. So the next question was, how many different ways can Alex and Brian be seated next to one another in the row? So in this case, the order mattered. This is what we call a permutation. Like, so if Alex is here, and then Brian's here, and then we have these 2 guys sitting here, well, this is not the same as Brian, and then Alex, and then Charles and David. Okay, and it's also not the same as Alex, and then Brian, and then David, and then Charles, and then we also would have Brian, Alex, David, Charles. So, and now this is just here. We can also move the ABs around. This wasn't all of them, but if you recall, we counted them all up, and there were 12 different ways out of these 24 that they could be seated next to each other. Well, this is called a permutation. Okay. And the way we could calculate those 12, a permutation is when you select items and the order matters, right? See how the order matters here? A and B is different from B and then A, okay? We counted them up when we wrote the sample space out up here. We counted them, we counted 12. Well, the quick way to do it, a little bit more sophisticated way, is by using the permutation key on your calculator. So what did you have? You had 4 spots. Right, you had 4 spots, right? Any 1, 2, 3, 4. I can, leave all these blank. And what I want to do is arrange 2 to be next to each other. I want to pick 2 guys, and I want to put them next to each other. So the order definitely matters in that case. So this would be 4 on your calculator. It's going to look like this. This NPR button 2, right? I have 4 seats. I'm going to select 2 of them, but after I select them, I'm going to arrange them, right? AB is different from BA. So I select the first 2 seats for them to sit next to each other in, but then I rearrange them after they've been seated. So what does that look like on the calculator? Again, we counted them all up and saw them, but this would be 4. We go to the probability button. We find that NPR key right there, number 1. You can press 1 or just press enter. And we want to permute 2 of them. Okay? And we get 12. Right? I'm going to go one step further. I'm going to answer a question that we didn't answer on this. But suppose I want to randomly select. I'm just going to use this so that you can see how to use the last feature on the calculator that we want to be concerned with, and that's a combination. And the key with the combination is that we select objects, but the order doesn't matter. So what does that look like here in this example? Well, the best I could come up with would be, let's forget about the seats. we're going to randomly select 2 guys that during the previews are going to go and get snacks. So we tell them what we want, tell them what snacks we want to order, what drinks we want, and we're going to send them out just 2 people. So the order doesn't matter. There would be no difference. If Alex and Brian got picked, there would be no difference between that and Brian and Alex. We don't rearrange them after we picked them. That's the nature of a combination. So that would look like this. We have 4 NCR 2. We're going to choose 2 people, and they're going to go get the snacks, and the order doesn't matter. They're just going to get the snacks, and then they come back. So what's that look like? 4 math. Oops, sorry. Go back. I want 4 probability, not math. NCR and number 2. So 4 choose 2, it's a little bit less. There's only 6 ways that I can pick people. So if you go back and look at that sample space, we can just eliminate the ordered arrangements of those. All right, so the key thing that you want to look at when it comes to permutations and combinations is this. Does order matter? After I select the objects, am I rearranging them? If that's the case, if you're arranging them and putting them in order, that's your permutation. It's this one here. If the order doesn't matter, right, when we select the objects from the group, then it's an NCR, it's a combination. If I'm arranging everybody, it's a factorial, right? That's just 4 factorial. We arrange all of them, 4 times 3 times 2 times 1.